We're going up, up, up to low orbit. Gonna be not re-entering. Gonna be not be burning up. Yeah, still not giving up my day job to become a K-pop singer. What is my day job? Well, my day job is working on this interesting thing, and we just got some good news. I'm Mike Siegel. I'm an astrophysicist. I write for Ordinary Times. This is the throughput. Anyway, my main job is being a research professor at Penn State University, and the bulk of my job is working with the Neil Gehrels Swift Gamma Ray Burst mission. This is a mission I did for here, video diary of a week in the life of Swift. Basically, this is a mission that studies gamma ray bursts. These are the biggest explosions in the universe, the birth pangs of black holes. And in addition to that, we study a lot of other transient phenomena, X-ray phenomena, ultraviolet phenomena, and we've been in space since 2004. This is a little model of the spacecraft made for me by one of our more brilliant students, based on a model by Christopher Meany did for NASA that was 3D printed. You can see the solar panels. This is our Burst Alert telescope that scans the sky for gamma ray bursts. These are our XRT and UVOT telescopes that do the narrow field imaging. And it's a pretty good model. Swift has been enormously successful over the last 20 years. We've been consistently ranked as a great mission in senior reviews. We get hundreds and hundreds of requests for observations every year. The number of papers written from Swift data, the number of collaborations we have it's something that I'm very proud to be a part of and is the highlight of my career. But we are in danger. When we were launched, Swift was in low Earth orbit, about 650 kilometers or so. Now, the atmosphere at 650 kilometers does exist. There's no hard cutoff for Earth's atmosphere, but it's very tenuous when you get that far out. But it does exist. And so what happens is when the spacecraft moves around the Earth, it encounters that atmosphere. Now, it's just very thin, small number of molecules hitting the spacecraft. But we're moving at thousands of kilometers an hour. And so those are big impacts. And so each impact slows the spacecraft down a little bit. And as it slows down, it begins to descend into the atmosphere. This is the process called orbital decay, and all spacecraft experience that. Now, if you're out at, say, geostationary orbit at 26,000 kilometers, it would take thousands and thousands of years for this to happen. But if you're in low Earth orbit, you're looking at years to maybe decades to re-enter. So Swift has been slowly and slowly descending over the last 20 years. Now, how fast it descends is difficult to predict. It depends a lot on what Earth's atmosphere is doing, and Earth's atmosphere is affected by many factors, including, most notably, the sun. The sun goes through an 11-year activity cycle, and during that 11 years, it will go from being very active, pumping out lots of coronal mass ejections and flares and so forth that affect Earth's atmosphere, cause the atmosphere to swell up, and increases the drag on spacecraft orbiting the Earth. And then it will go quiet, the drag drops off. Swift has been up for 20 years. The cycle is 11 years. We're through 2 cycles of the sun's activity. The first cycle was relatively gentle. We didn't fall very much. This last cycle has been a lot more active. And so we have, you've seen those beautiful aurorae. I did another video on that one that were really beautiful, but meant that Earth's atmosphere was interacting with the spacecraft more and dropping it. Orbital decay is one of these things, like most bad things in life, that happens very slowly and then all at once. It took us about 20 years to drop from 650 to 500 kilometers. It's going to take us maybe a couple of years to drop the rest of the way. And we're dropping very fast right now. As we get lower and lower, the atmospheric drag increases. And so that's why it's exponential. That's why it starts happening faster and faster. You're getting more and more atmosphere, more and more ram pressure, more and more descent of the spacecraft. And, when you get to about, say, maybe 100 kilometers, that's when the solar panels and other delicate parts of the spacecraft begin to snap off. When you get to about 80 kilometers, 60 kilometers, that's when the spacecraft begins to break up. We don't know where Swift would end up. Most likely the ocean, since most of the Earth is covered by ocean. Some of the heavier parts might reach the surface, like some of the mirrors and so forth, but wouldn't be a lot of debris left. And for a long time, I knew that was our fate. And people would sometimes ask me at public events, well, could we send up a spaceship and boost it to higher orbit? And I would sort of grin and grimace and say, no, not really, because it's cost so much to launch something into space, a couple $100 million. For that price, you could build a new Swift. You couldn't really, but you get the idea. But that equation has changed in the last 10 years. We've had SpaceX and other companies start dropping the cost of launch dramatically. And some of these spacecraft, like when SpaceX launches their satellite system, they can launch many satellites at once, many small satellites at the same time. And so you can sort of share the cost. And that means that the idea of rescuing Swift before it burns up in the atmosphere is not as far-fetched as it used to be. Now, earlier this year, NASA began talking to 3 different aerospace companies, startups, about a potential rescue mission for Swift. And a couple months ago, we announced that a contract had been awarded to Katalyst Space to try in May or June to send up a spacecraft. It'll be much smaller than this relatively, but I want you to be able to see it. That will rendezvous with Swift, latch onto it, and then slowly boost it back to high orbit, hoping for maybe 600 kilometers. Higher would be great. And if successful, that would give another decade of life to Swift, assuming nothing else breaks on the spacecraft. This was not a possibility even a year ago, but we have now multiple companies that are interested in this segment of space science, of being able to rendezvous with spacecraft that were not designed to be rendezvoused with for potential servicing. And Swift is very lucky. We happen to have this need to be boosted right at the time when interest in this technology is coming online. And we had, as I said, 3 different companies that were interested in this. We're also lucky because the spacecraft is big enough that you could latch onto it. It's not too small, but it's also not so big that it's too heavy to boost up to low orbit. A lot of spacecraft would be way too heavy for this kind of thing. And so we're very fortunate that this is now a possibility, and NASA has now approved this. Now, I don't want to oversell this. This is still very cutting edge science. Just because we're going to attempt it doesn't mean it's going to work. There are immense challenges in doing something like this. Just for example, you have 2 spacecraft attached to each other, each of which might have its own crackpot ideas of where they should be headed, and you have to find ways to figure out how to make that work. There are other technical problems that I can't get into, partly because it's kind of confidential information, partly because it's what we call export controlled. I can't talk about it in a public space like this, and mostly because I don't understand a lot of it. I don't mean to be pedantic or anything, but spacecraft are complicated. And so I've been sitting in on a lot of these very complex discussions of how to make this work. However, all those challenges notwithstanding, if it can be done, I think we've got the right people to do it. My experience with the Katalyst people is that they are very smart, they are very thorough, they are very good listeners, which is important when you're talking about a 20-year-old space mission. And if it can be done, I think they can do it. So in a time when all the news about space science and space exploration has been pretty bad the last year or 2, this is some good news that we might be able to rescue a very successful NASA mission and give it another 10 years of life. It's obviously good news for me because this is where my funding comes from mostly, and I've been working on it for 15 years. I really would hate to see it go to waste. It's good news for the astronomical community because Swift does a lot of cutting edge science that doesn't have a space right now. There's not a mission that's going to replace it right away. There are missions that may replace it down the road unless their funding is cut. But for right now, Swift is it when you're talking about time domain science and ultraviolet and X-ray. Swift is filling an extremely important niche right now. And I would hate to see that part of the science go quiet. But I also think there's possibilities beyond Swift, because this is just me speculating and thinking about what might be done with this technology. Because if you can rendezvous with spacecraft that are not set up for rendezvous and service them, either boosting them to high orbit or something like that, the possibilities are endless. Imagine if you launch a mission and it doesn't quite get into the right orbit. 50 kilometers off. It might be worth a few tens of millions to launch a small mission to boost it back to the right orbit. Save a $500 million mission. Let's say you have a spacecraft. When we launch spacecraft, there are terrifying moments when the solar panels unfold and the telescopes open. Those are moving parts, and so if they don't open, you don't have a mission. Imagine if this solar panel didn't deploy. Well, we can send up a mission to rendezvous it and potentially deploy that. I think, to the point where it would make sense for future missions to have points for spacecraft to latch onto to make a rendezvous easier. I think it's especially interesting to think about this when it talks about space junk. There is a lot of stuff out there right now, and a lot of scientists are worried about the possibilities of Kessler syndrome. When things collide in orbit, they create this cloud of debris. They collide at very high velocity, so they create this cloud of debris. And there are worries that if you got enough collisions, you could create what we call Kessler syndrome, where you have a chain reaction that fills the sky with junk and makes space travel impossible. Many of these things that are up there are unguided or dead spacecraft, or spacecraft stages, rocket stages, things like that we have no control over. There's no way to deorbit them right now. But if you could send up missions that could deorbit these things, you could potentially save space travel that way. So I don't know what the plans are of these companies for these rendezvous. Maybe they're thinking much smaller than I am, but this is a ray of hope for space. And we really are, I think, no one talks about it this way, but we really are in a golden age of space science. One of the videos I'm working on is from a movie set in the 1960s about space, when we were in this golden age of Apollo and all that. And one of the things I commented was saying, people don't talk about how we're in a golden age right now between SpaceX and Blue Origin and these startups that were working with us on this rescue mission. There really is a lot of amazing work being done right now. And I don't think a lot of people appreciate just how extraordinary the field has gotten in the last decade or so. So I won't have another video on this for another 6 months, probably until we get close to launch or after launch to update you on how it's gone. Of course, you probably won't need me. It will be in the news if we manage to rescue it. But this is exciting stuff, and an unexpected rescue, not just of my mission, but of my career. So I'm very happy about that, obviously. But it's an exciting time for space science. Even if a lot of the news is bad, there are still a lot of rays of hope for the future of space. And so I just wanted to give you guys some good news for once, and whet your appetite for what's coming in next year. And we're looking at a May or June launch, and so that's going to be a very fun time. And hopefully you'll be hearing very positive things from this around then. This is one of the reasons the summer has been very busy and I haven't been pumping out as many videos as I'd like, but we got a lot more coming. So stay tuned to this channel and we'll hopefully get some more of those out. In the meantime, I'm Mike Siegel. I write for Ordinary Times. I can't wait to see what's going to happen with this thing. And thank you for watching.